How you doing? My name is David. I'm going to be performing a Python code in Google Colab using machine learning techniques, classification technique with the Iris dataset that I got off of UC Irvine, which is a free download, so anybody can use it. All right, so let's get ready to get started. So the first thing we want to do is log into Google Colab, which I've already done. Uh, it's a free software that you can use. So with getting started with this, the one thing that we want to do is import our libraries. So first thing is, let me go on and comment that. All right. And with this, I'm going to be doing a couple of different classification techniques. So I'll actually be using the K-neighbors classifier in sklearn. Also, the metrics, I'm going to be using a accuracy score, classification report, and also a confusion metrics. Um, the import pandas is used to do data manipulation and loading the data set, the Seaborn, and then also the Matplotlib. The lib is for creating visualizations, which you'll see a lot of the graphs that I'm going to use in this program. And then the sklearn is for splitting the data set and building a classification report. So what I want to do is make sure that everything is good. So I'm going to run it. All right, so that worked out. I'm going to add another code onto here. And this is where I'm going to actually load the data set of the Iris CSV. So let me comment that in there. All right. So with this, the data equals to pd.read underscore CSV. What that's going to be doing is going to be pulling the Iris CSV file that I have on my computer. I did upload it into Google Colab, which you can see right here. Upload. You would just push this, the upload button. It'll pull up, and then you can pull it from your files. So I want to make sure that everything loaded. So the other thing that I'm doing right now is I am commenting what the iris df is, so the data frame. That way I don't have to comment it again later on while I am doing the code itself. It will already be referenced. So let's make sure that everything loaded up correctly. Okay, so the CSV file did load up. You do see the sepal length, sepal width, the petal length, the petal width, and then also the class. Okay, I can clear that out right now. All right, so next up, what I would like to do is pull in the basic data. So with that, I'm going to be describing what the iris data frame is. Also, I'm going to incorporate the Seaborn uh, Seaborn, so the Seaborn visualizations, and then also the Matplotlib uh, visualizations. A lot of these are getting ready to be shown. So you're going to see the scatter plot, which will give a nice graph and show a nice classification between all the classes. So what I'm going to do, I want to summarize the information that I have from my CSV file. So I'm going to summarize that in a scatter plot. And with using the scatter plot, the pair plot is just to give a visualization between all combinations of the features. And so all of them are going to be colored by class, which helps understand and define each one from each other. So let me go on and put that in. All right. Okay. Let's see if that's going to work. All right. So as you can see, each class has its own color. It also has its own shape. So that way you can see the difference between each of them. So it's a better visual representation of everything. Let me clear that out. So the next thing I want to do is I want to show each distribution of the features. So let me go on and comment that. All right. Okay. And while I'm at it, I want to compare the features of the distribution across each class. So let me go on and put that in too. Okay, let's run this again. Alright, so as you can see, the first one that we had was the summarized information placed in the scatter plot, which was this one here. The next one is going to be the distribution of each feature, which shows a nice histograph. And then we also have a box plot. So with that, the visualization of it, so showing the histograms of the sepal length, the sepal width, the petal length, and the petal width, it gives an overview of the distribution. Then the box plot itself allows to compare the features across the classes. So you are able to replace the box plot with with the instead of it being sepal length, you are able to place it with the sepal length, the petal length, or the petal width to get different visualizations. So since these worked out, what I want to do is add more to it, and then I can clear this out. So let's clear that out. Next up, I want to define the matrix and the target variables that I'm going to be doing. So okay. So this is going to give me that X and Y axis, which I'm going to utilize in the linear regression and also the prediction, which will be in the next code process after that. So right now I want to split the data sets into training and testing sets. So it'll give the X train, the X test, the Y train, the Y test. That way it will be easier for us to understand, us to do the prediction of it. So let me go on and comment that also. All right. So the other good thing that I like about Google Colab is that it does have the predictive modeling. Also another portion of machine learning, which the Google Colab is using Gemini to kind of predict what I may use next. Um, Although I'm not using any of the things that is showing down here where it says scale the features, I'm not using any of those. So what I'm gonna do is I'm gonna run. Okay, we got the check mark on the side, everything is good to go. Now I'm going to add another code. This is where I'm going to scale the standard data, and what I was doing with this portion up here is data pre-processing. So that is splitting the data set into features and labels to perform the data process, the pre-processing portion of it. So that train split, it splits the data set into training and testing sets, and then I'm going to be using a standard scaler to standardize the features and remove mean and scale into a variance. That's useful in a lot of machine learning algorithms. So let me pull that standard data. And I've already performed the code itself. I've made sure that it worked. Um, Sorry, I got the wrong one. So all of this is based upon the process that I've already done to make sure everything worked out. All right, so pulled in the standard data. I do have everything scaled, like I was saying earlier about the scaler. Now what I'm gonna do is use a K model or KNN model. Uh, and what that is going to do is basically called a K nearest neighbors, and it's going to classify the flowers. So, all right. And then the next thing I want to do is I want to view the results. So I'm going to print the accuracy score and then also the classification score from that. So this is a way to check how well our model is performing. um, and give the prediction of what the K-neighbors KNN model is asking. So the Y predict, the KNN predicts, the X test scaled. All right. So let's run this, and it gives it as a 92, well 91.6, and it goes on. But round that up, that's a 92% accuracy. As you can see down here, the accuracy, the macro average is 92%. The weighted average is 92%. The precision, the recall, the F1 score, and the support. And so the accuracy score that we're seeing right here shows the overall performance of the model. The classification report gives the precision, which will bring these right here, the precision, the recall, the F1 score, and the support itself. And those are all based upon the information that we put in. All right, so let me clear this out. And let's add a confusion matrix to it also. So the confusion matrix is going to show the number of correct and incorrect predictions of each class. So these are a couple of things that I looked at on YouTube to kind of add some more to this project that I'm doing, and kind of give a better visualization of the project itself. So, all right, all right. So you see the accuracy score right here, the classification report. Now you see the confusion matrix down here, which has the actual prediction, and then also the actual, and then what the predicted is, and then it gives the numbers to that. So it puts everything into a nice visualized graph onto it. This whole project itself was very fun for me. I know it was something that we did in the beginning of the course, but what it did is it helped me out with going back to the foundation that I'll be able to utilize later on in machine learning. So continuing to work on the foundations helps out with going into more complex machine learning uh, algorithms, that if you work on the foundation of it, it will be easier. So thank you for having me in the class, and thank you for everything. Have a nice one.